Welcome to Brain Vision.
Hi everyone, so what we have is a balloon that is filled with steam at an initial volume of 50 cubic meters, an initial pressure of 100 kPa, and an initial temperature of 150 degrees C. There is a supply line at 150 kPa and a temperature of 200 degrees C that is actually filling up this balloon with more steam. The valve for the supply line closes when the final pressure equals the same pressure as the supply line of 150 kPa. We know that the volume is linearly related to the pressure, and at the time when the valve closes, the mass inside the balloon at the end is 2 times the initial mass. So what we're asked to find is the temperature and the boundary work. So what we're going to do is first find our specific volume. So for the initial condition that P1 equals 100 kPa and T1 is equal to 150 degrees C, we know that the initial specific volume will be equal to 1.9367 cubic meters per kilogram, and this information can be found in the thermodynamic table A6. We can actually use the relationship that the pressures and volumes are linearly related to solve for the final volume. So this we can simply write as V2 is equal to the final pressure over the initial pressure times the initial volume. We know P2, P1, and V1, so we can actually go ahead and compute the final volume, which will be equal to 75 meters cubed. And next we can also find the initial mass. So the initial mass we can just solve using the definition of specific volume and rearranging some terms. So we can say that the mass is equal to the total volume all over the specific volume. Recall that we did solve for the specific volume previously, so we can actually go ahead and compute this, and we get the initial mass to be 25.82 kilograms. Now what we can do is solve for the final temperature, and we have to first solve for the specific volume at the final state. So V2 is going to be equal to the overall volume over the mass at the final state. However, we do know that the final mass is going to be 2 times the initial mass, so we can go ahead and plug that in. Now we did solve for V2, that was 75 cubic meters. We know the initial mass was 25.82, so we can actually go ahead and compute the specific volume at 2, and that's going to be equal to 1.4525 cubic meters per kilogram. Now using this V2 and the final pressure of 150 kPa and our specific volume 2 of 1.4525 cubic meters per kilogram, we can refer to the table and find our final temperature. And we find that this final temperature is equal to 202.5 degrees C. So that is going to be the final temperature inside of our balloon. Next, when we look for the boundary work, we know that the volume is changing linearly with the pressure. So that way what we can do is just take the average of the 2 pressures and multiply that by the difference in the volume and get us our boundary work. So what that looks like is the boundary work is going to be equal to P1 plus P2 all over 2 times the quantity volume 2 minus volume 1. And when we plug in all of our values here, we get a final boundary work of 3,125 kilojoules. And that's our final answer.